Let's just talk. So you've had a chance to see the answers. We're good there? Okay. Excellent. Here we go. So what does all this mean? Well, we have an algebraic definition of what geometric mean is. That's this equation, this proportion here. I want you to see that this same type of situation where the means show up in both parts of your proportion happens in a geometric figure as well with right triangles. This is a key thing to solving for missing parts of right triangles, which is all we're doing really today. So again, draw the same picture as we had up in 8-1. You're going to use it down in both of these theorems. And make sure you leave a little bit of room at the bottom, though, because you're going to need to write some things. Careful, careful, careful. There we go. If CD, no, we're not going to use the letters. We're going to use the actual lengths this time. So there's a convention when drawing triangles that if you want to label the side lengths, giving them a variable, then you use the letter right across from it. So this side's going to be length B. This side will be called length A. And this side would be called length C. However, it's been broken up into two pieces. You see that? So we'll call the first one C1, the second one C2. And we're going to call this altitude G, as in geometric mean, G. Do the same thing to the bottom picture. B, A, C1, C2, and G. That's smeared. Let's see if we can get that. There we go. So the geometric mean theorem, as it applies to the altitude, we can say if G is an altitude of triangle ABC and angle C is a right angle. So basically we're just saying, hey, we have a right triangle and we put an altitude in it. Okay, those conditions, gang, you're going to write down on the second theorem as well. It applies to both theorems, because this is just the same theorem, just teased out in two different pieces. And the boxes on the right are just going to be our proportions. We're going to make proportions now. That light's just a little too bright. I'm going to dim it back a bit. Not too bad. That's a bit better. All right, so to keep track of everything, I'm going to list the triangles, and then we're going to list the proportions, kind of like a row and column, exactly like a row and column. The first column will say small triangle, abbreviated. Second one will say medium triangle, and the last one will say large triangle. Makes me think of a joke. Did you guys hear about the 4-foot-tall psychic who broke out of prison? Police says that there's a small medium at large. Terrible joke, Mr. Duncan. A small medium at large. Okay. So you ready for your proportions? We're just writing a bunch of proportions down, okay? So the first one we're going to do, let's use the altitude. If you notice, this altitude is the long leg of the small triangle, and it's the short leg of the medium triangle. So let's do short over long. So that stands for short leg over long leg. Because you notice these triangles, each one has a short leg and a long leg. Okay. So on the small triangle, that would be C2 divided by G. on the medium triangle, the short leg would be G over C1. So can you see right away that this has the same exact setup as a geometric mean? It's using the exact same formula, right? A number, and then the geometric, or the altitude is showing up in the same spot. Okay. So this is handy because before you needed 3 numbers to solve for proportion. Now, if you know these 2 numbers, you can solve for G. You can solve for that altitude now. So that's a really useful piece of information to solve for missing parts of right triangles. So, and of course the last piece, okay, because we want to complete the proportion at least. The short leg on the big triangle would be B, and then the long leg would be A. Nothing special there. We don't see that geometric mean kind of thing showing up there, but we're just completing the proportion, because you can see it here very clearly. Okay, I want you to come up with that same drawing, that same apparatus we drew right down here as well. So small triangle, medium triangle, at large triangle. Admit it, it was a funny joke. All right, Mr. Duncan, okay, if you say so. Okay. This time I'm going to try short over hypotenuse, see what happens. So if we do short leg over hypotenuse. On the small triangle, actually let's do this by a roll if we would. Team 6. So that's Francisca's team. Could you tell me, what is the short leg on the small triangle? What length is the short leg? C2? Okay, C2. And let's see here. Team 1. So that will be right here. It's Miguel's table. What is the hypotenuse on this small triangle? Which length? What is Team 1? So it's right there. Team 1. 1, 2, 3, correct? I'm so sorry, Christian. I'm so sorry. Did it again. Oh no, the Castro brothers are going to hate me all over again. Next new week of hatred. Okay, so Team 1. Okay. What is the hypotenuse of the small triangle? Yeah, it's B. What? You guys are like fearful or something. I don't know why. It's just figure out the length. But yeah, you're absolutely right. Team 5. Mr. Serta, I believe that's your team. Okay, there's not any other Sertas, right? Yes, okay. Mr. Serta, what is the short leg on the medium triangle?
It's G.
Okay. Alexa, you agree? You agree it's G? Okay, fantastic. And let's see here. Roll again. Team 4, right next door. Okay, and you're saying A is the hypotenuse on the medium triangle? Oh, excellent. Okay, and let's get the large triangle. So again, I don't see the geometric mean kind of phenomena showing up yet. Team 3, that's going off really well. Everyone's getting a shot here. I love these dice. So let's see here. Ivana, your table. What is the short leg of the big triangle? What's the shortest leg on this large triangle? There's 3 lengths. One looks longer, one looks shorter than the rest. So B is definitely the shortest leg. Thank you. Okay, and table 5 again. Team 5. Alexa, your team again. What's the hypotenuse? Very good. And we'll just call that whole thing, C1 plus C2, we'll just call it C. Okay. So you see a geometric mean showing up there at all? That formula? Yeah, if I just cover this middle term, notice what you see on both sides. You see the B shows up in the top and the bottom?
Yeah, just switch to C2.
Right. So if I compare the small triangle to the large triangle, I could solve for B, in essence. Nicely done. Okay, I want to do one more comparison. Let's go a little bit faster because you guys are squirming in your seats to be called on. What's so worrisome? So very, very worried. Let's see here. We have hypotenuse and long leg. Let's try hypotenuse and long leg and hypotenuse. Long leg over hypotenuse. We'll try that one next. Okay, on the small triangle, what's the long leg? Class, what's the long leg on the small triangle?
G.
G, what is the hypotenuse? B, very good. I know it's tricky going between all these little triangles. The medium triangle, what's the long leg?
Wait, C1. Oh, G.
G is not the long leg.
That's
C1!
I thought it was C, I'm sorry.
You can't see this.
No, like I can, but I just
Oh, it's hard to make sense of? Yeah. So I'm just looking at the medium triangle so far. And what's the hypotenuse? A. Okay. A. There it is. Okay. And lastly, large triangle. Look at the big triangle. What is the long side?
C1.
The long side?
C. Is it C? Oh, C.
Guys, there's the right angle right there.
C1.
The long leg. Okay, you're looking at the big triangle. I'm covering up the rest, so you only see the big triangle. What's the longest leg? A is the longest leg. This is the hypotenuse of the biggest triangle. Okay, so because this is the right angle on the big triangle, across from the right angle is the biggest side, right? Right? So A over hypotenuse would be C. Okay, have a look here. What do you see? Geometric mean shows up again, doesn't it? So you can use these ratios to solve for missing side links. That is the big thing we're trying to get you to take away from this. All right, if you would please turn the page. Once you've got these notes, of course, you got these notes. All right. Now, we're going to jump over the first one because this theorem 1 just says, hey, can you list the 3 triangles in order? It's basically what we did in theorem 8-1. It's just you just doing it all over again. So you don't need me to do that with you. Look at example 3. This is where we actually get to see some usefulness come out of what you've been learning. So gang, a lot of the stuff you've learned up to this point in the semester has been a lot of theory, right? A lot of proving something is true or not true, but not a whole lot of application in the real world. After today, you'll be able to measure how tall a tree is. Easily. You can measure how tall a building is. Using mathematics and your mind, yes. Absolutely. Absolutely. So let me prove that to you. There's a person, he's looking at the tree, he figures out, he walks back from the tree, and the thing it should also tell you is that this is a right angle he's making. So he's looking at to the top of the tree, looks like a really weird nuts right now, I know, and looking to the bottom of the tree, and what he's done is he's made a right angle of a line of sight from the base up to the top of the tree. So all you need is a piece of paper to do that, right? You get a piece of paper, look up till you see the top of something, look down till you see the base of that thing, and that makes a right angle. Make sense? So he's made a right angle, we got that. So we can use these properties of similar triangles now. I see that we know this piece right here, which is basically his eyesight height, how tall he is up to his eyesight. What we're trying to find is what, though?
The height of the tree.
Yes, so do we know the height of the tree yet?
No.
No. Do we know part of it? We know this piece, right? Right, so we just need to know the rest of it. Let's call that T for tree or trunk, I don't know. Top, okay. So let's see here, we need to solve for T. Well, if you look at it, T is part of the medium triangle, would you agree? Which leg of the medium triangle is it? Short leg, long leg, or hypotenuse? Yes, the long leg, so that's the long leg. The only other triangle that we have information about is the small triangle. Do we know the long leg? Right there, 7.8. And we know the short leg is 1.6. So we look at the medium triangle again, and we don't know the long leg. That's the thing we're trying to solve, but we do know the short leg. So if we do a ratio of short leg to long leg, we should be able to set up a proportion to solve for it. So let's do that right now. We're going to say, we can say short over long. If you wanted, you could say long over short. It would also be fine, right? It's okay to set it up that way. So short leg to long leg would be 1.6 compares to 7.8. The same way that on the medium triangle, what's the short leg again? On the medium triangle. 7.8, thank you, compares to T, because we don't know what T is yet. So now you cross multiply and you solve for T. So this is a handy application of the geometric mean. So I think we're going to get 1.6T equals 7.8 times 7.8. Divide both sides by 1.6. I can hear the calculators typing furiously. And you end up with something like 38, is that right? 37, 38? What do you find out? What'd you get, guys? Did you?
7.0, no.
Well, make sure you divide by 1.6 as well. So multiply and then divide.
38.35.
38.025? Okay, meters. So this is our answer, yeah? That our answer? Should I box it?
No, because we're just finding the side of the.
Oh, because it said find the height of the tree, so we have to do this number. Yeah, because I forgot to add on the 1.6 to it, didn't I? So I still have to do one more thing with this. So 38.025 plus 1.6. Well, that's pretty easy math. 39.625 meters. So check it out. He did not scale the top of the tree, or she. They did not scale up to the top of the tree to figure out its height. They used some simple mathematics, not overly complicated mathematics. They figured out the height of this tree. Which means if we want to find heights of other things even taller, we could do so. We just need to get some basic numbers. Look, 2 numbers and you can figure out everything about this triangle. So moving on to example 4, because this is where some more rubber hits the road. Have a look. What information do they give us? Okay, I know the 4 represents the short leg on the small triangle. 25 represents what? Long leg on the medium triangle. So your eyes are starting to adjust. You notice that? You're responding much quicker. And I guess if you needed to, you could also say that we know the hypotenuse, right? Because the hypotenuse would be 25 plus 4 of the big triangle. All right, well, let's solve for x first. Let's see if we can solve for x. What's a good proportion we could set up to solve for x? What do you guys think? Sure. 25 over x. Okay, so she's saying long leg over short leg. Okay. What should we compare 25 over x to? So that's long over short is equal to, has to be long over short again of another triangle, yes? Well, on the big triangle, we would have z and y. That wouldn't solve anything there, so we can't use the big triangle, obviously. So I guess we're going to have to try the small triangle, yes? Okay, what's the long leg of the small triangle? Y is, right? X is, excuse me, right, because it's that's what the 90 degree is right there. So, yeah, that's the long leg. The short leg is 4. Hey, we can solve that. So you did long over short is equal to long over short. Now when you cross multiply, you get x squared equals 100. Therefore, x must equal 10. Nicely done. So now that we know that x equals 10, technically we could use proportions throughout, or we could use the Pythagorean theorem. I'm aware that you are very comfortable with the Pythagorean theorem. You know it, you know how to use it, you've used it a lot. Therefore, I strongly caution you not to use it to solve these problems. Not because I don't want you getting the right answer, but because I want you to practice setting up these proportions. So that you're so familiar with how to set up proportions, you could use that or the Pythagorean theorem whenever you need to. Because there's going to come a time when the Pythagorean theorem is available and you can use it, like right now. Now we have that number. But we couldn't use it at the beginning. Right? We didn't have enough information to solve for it at the beginning here. Now we can. So practice using those proportions. So gang, look at y. How can we solve for y now other than the Pythagorean theorem? Give me a proportion. Tell me more.
Well, the shortest side is now 10 for the medium triangle. And
Okay.
The shortest side for the smallest triangle is 4.
Okay, so you can compare shorts on the medium. Okay. Y on the small triangle would be the hypotenuse, yes?
Yeah.
So if we use the medium triangle, the hypotenuse is going to be z. So I'm guessing we don't want to do short and medium in terms of a comparison. Let's try another one. Okay, so y is definitely part of the short. What else is y a part of? It's part of the small triangle. What else is it a part of? Which triangle? The big triangle. What is it on the big triangle? Ah, so we have short on the small triangle. We have short on the large triangle. Y is the hypotenuse of the small triangle. What's the hypotenuse of the large triangle? 29. So let's see if we can do that. So let's just set it up. So you're saying let's use short leg and hypotenuse. And guys, when you do this in your homework, you're not going to get it right every time the first time. You're going to do some trial and error and go, oh, that didn't work. That's okay. You're going to try setting up a proportion. It's not going to work out. be willing to try using more than just the two triangles. Maybe you just need to use, instead of short and medium, or small and medium, maybe you need to use small and large. That's okay. So modify your triangles until you start getting a feel for which two you need. So you're saying 4 compares to y on the small triangle, short side, hypotenuse on the small triangle. On the big triangle, short side is y, okay, and the hypotenuse is 29. Hey, we can solve that. That's solvable.
Which triangle did you put in?
4 and y, so that would be the small triangle. And then y and 29 would be the large triangle. We did small to large, right? Because those proportions we wrote down said you can use any two triangles, right? So cross multiply, we get y squared equals 4 times 29. Notice I'm not going to multiply those numbers and actually give you the product. Why not? What are we going to do to solve for y? Got to take the square root next anyways, right? Which means we're going to factor out any perfect squares we have. So if we do so, we're going to get y is equal to 2 times the square root of 29. I know that it feels weird to leave that 29 in there because it's so big, but 29 is a prime number, gang. It don't factor. There's nothing we can pull out of 29. Prime numbers, they don't factor. All right, we're doing good. Nice work. Okay, so Z. Z is part of which two triangles? Big one and the medium. So let's use the big and the medium triangles so we can try setting up this geometric mean thing again with it. It's going to be the hypotenuse of the medium triangle. Can you see that? If I cover this little piece up, you can see that medium triangle. And Z is also the long leg of the large triangle. Would you agree? So let's do long leg, over hypotenuse again. Or long over hypotenuse, I guess for the first time. So on the medium triangle, the long leg is 25. Can you see that? And the hypotenuse is Z. On the large triangle, the long leg is Z, and the hypotenuse is 29. For the hypotenuse of the big triangle. I know. It's hard because you have to keep changing, don't you? All right, guys, this should be easy to solve. When we solve, we get Z squared equals 25 times 29. And if I take the square root, what do I get? Z is equal to... See, you guys are already seeing in your head, 5 root 29. You nailed it. Okay, I wanted to grade homework today, but it didn't happen. Before you leave, please put your homework in this folder, right there. Okay. You only need to do the homework for 8-1 because we did not get to 8-2 today, and that's okay. I spent more time on geometric mean to make sure it sits well with you. Okay. Second section is really easy anyways. For homework tonight, you need to take notes on 8-2 and start working through the notes on that back second page. Okay. You will be doing it as part of your warm-up tomorrow, or Thursday. Okay, wonderful. Work on your projects, and I will see you Thursday. You're welcome. Why? This is why I can't have nice things. I blame you for this. Yeah, sure. You can. Yep, absolutely. 8-4? 1. Oh, we haven't even taught 8-4. Okay, yeah, sure.
I was going to ask about my homework because I've turned in multiple homework.
Any homeworks that I have of yours still?
No, like newer ones.
Any homeworks that I have of yours still would be in those folders in the back. If I have nothing left, that means I've returned everything. So if I've returned it, it's now yours. If it's not updated properly in the grade book, feel free to take a picture so that you can look. It's right here. Okay, and I gave you the grade sheet so you can staple to the back and you hand it.
Yeah, you emailed my mom and
she asked for it.
Yeah, and that's what I was like trying to figure out because there's like a few things that like I feel like the newer homeworks, like 3 of them that I've turned in and they say that they're missing.
Right. So it could be they got grouped together with somebody else's papers when I was doing all my grading. It's possible, and if it is, by all means, have a look. Okay. Because I've given back everything that we've graded so far.
Can you do me a favor and send my mom an email telling her that I came up here and talked to you because she needs that?
Sure. Yep. You email me and I'll email her. That's fair.
Whenever I input the video, I use this like as a guide.
Oh, wait a minute.